Hello and welcome to another video tutorial on autonomy. My name is George Burke and I'm a research engineer at Argonne National Laboratory, and in today's video we are going to discuss how to stop a simulation of a battery electric vehicle when the minimum SOC is reached. So let's start the demonstration. So from the select vehicle here I have selected a battery electric locomotive in this case, and all the files are located here. So you can go here to rail freight, and this is the vehicle that I have selected. And I wanted to show you some of the default parameters over here. So if you go to parameters tab and type ESS, and you can see some of the values like the maximum allowable SOC of the battery pack is 100% mentioned over here, but it's not showing all the values. So we'll click on overwritable, and then we'll click eval so that we can see the default values of various parameters of the batteries. So the initial state of charge in this case is mentioned as 100%, and the default minimum SOC is mentioned as 20%. So this is how the default settings look like, and we will run a simulation with this and see at what point the vehicle simulation stops. So we will select the duty cycle, Amarillo to Clovis duty cycle. We'll go to run simulation and launch the simulation. So in this case, just wanted to reiterate again that the initial SOC was 100%, and the minimum battery SOC is 20% in this case. And the steps that we are taking in this case, in this example, which is for a battery electric locomotive, you can take the same steps if you want to implement the same thing in case of a battery electric car or a battery electric truck. So the steps going to be the same. So the simulation is running. We can get results in few seconds. Okay, so the simulation is done now, and we can see the results in the GUI. So you can see here that the requested distance of the duty cycle was 101 mile, but the distance traveled by the battery electric locomotive is 46 miles. So the simulation is stopped in the middle, but did it stop when the battery SOC was minimum? That we can check here. So in this case, the initial SOC was 100 as we set, and the final SOC is 5.6%. That means the vehicle did not stop at 20% SOC, but it ran beyond that. So we can see here that at this point, the vehicle simulated speed started deviating from the requested target speed, and after some point it became zero. So one thing is clear from this is that the vehicle did not stop at 20% SOC. And if you want to look at the values in more detail, we can go here, and I want to show you the vehicle simulated speed, and we can go to linear speed out. So this shows the actual simulated vehicle speed. It did not cover the requested 101 mile distance, and if we plot the ESS on the same figure, then we want to see how it looks like. So we'll type ESS, and when we see the SOC over here, so one interesting thing to notice here that At 20% SOC, the vehicle was at this stage where the speed was around maybe 45 mph, and after 20% SOC the battery further depleted and came to at this point. And when the SOC was around 14%, we have a regeneration event where the battery again got recharged beyond 20% SOC, and then again started discharging as the vehicle moves, and finally becomes 5.6%. So we have a we can see a regenerative event after the 20% SOC, and that was the reason the vehicle was able to travel more distance even after the battery at this point was 20%. So what if we want to stop the simulation or the vehicle when the minimum SOC is reached? So to implement that, we will again go to edit vehicle, and in this place we'll type VPC, which is vehicle propulsion controller, and we can see this parameter which is called VPC prop init stop at low SOC. So by default this value is set to 0, and if we want to stop the vehicle when the minimum SOC is reached, then we need to check this box, and then the vehicle will stop at minimum SOC. So sometimes if you want to find this, you might not find it here. In that case, you need to check whether the overwritable box is checked or not. So make sure this box is checked, and then check this box and run the simulation, and let's see how the simulation results look like in this case. So if the box is checked, the vehicle simulation should stop when the minimum SOC is reached, and that's how we want to see it when the simulation results is populated. So the simulation is going on. Let's wait for it to get finished. All right. So we'll go to the main results tab, and we can see in this case uh, we'll start from the beginning. So requested distance was again 101 mile, the same duty cycle, but in this case it traveled a distance of around 30 miles, which is 16 mile less than the previous case. And the reason being, uh, it stopped exactly when the vehicle SOC was 20% and was not able to utilize the regenerative braking or regenerative phase that was coming just after the 20% SOC mark. So in this case, when we go here, we see that started with initial SOC of 100% and the final SOC of 20%. So it stopped at 20%. And if you want to see a little bit in more detail, I can plot the vehicle speed over here, or let's plot the ESS SOC variation in this case first. So you can see the orange line over here, which shows that the simulation is stopped at this point. The line ends at this point. So when the battery pack SOC reaches 20, the simulation is stopped. And if you want to see the vehicle speed, so sorry, we need to type chas plant linear speed out. So in this case, we can see the speed, the vehicle is stopped at 20% SOC. So this purple line, which represents the vehicle speed, is stopped at this point. So in this way, we can see how to implement the changes if you want to stop the vehicle exactly at a specified minimum SOC. So we need to change the stop at minimum SOC value for the VPC, and we can make the changes in the simulation. I hope you like this video and it was helpful if you want to do something like that. and I will see you in another video. Thank you.